All right, so let's take a look at object adapter. Right, as I mentioned earlier, there are two flavors of this idea. One of them uses inheritance, right, where you inherit all the implementations of some base class, but you implement some interface. So this one is somewhat similar, but not quite. Right, it still implements the interface, right, because the client is expecting something of a particular type. Right? And the only way to do that is implement that interface, right, so that we can pass it along. But instead of inheriting from some base implementation, right, instead it's going to keep track of a delegate instance, an instance of some other implementation, right, that has all those methods, right. So instead of using inheritance, we're going to use delegation. Right. Right. So instead of inheriting the implementations from some base class, right, we're going to keep track of an instance, right, of that other class that implements all these methods, and we're just going to forward all the invocations of methods to the interface. We're going to forward all those methods to the adapter, to this delegate. Right. Um, Again, the client might be expecting an object of a particular type, the adaptee, but instead, I'm sorry, the target, but instead we have something of type adaptee, right? And the same strategy, we're going to implement the interface, but implement it in terms of the object that we actually have, right? Same name, adaptee to target adapter. It's going to implement target, but it's going to use an instance of adaptee as opposed to inherit from adaptee. Okay. So in UML, we still have the same thing, right? We have the client is expected to be able to use an object of instance target, but instead we have something of type adaptee. Okay. So what we could do is to create the adaptee to target adapter. Notice it's the same class that we were implementing earlier, right? But the strategy is going to be slightly different. We still implement the interface, same as before, right? But instead of inheriting from adaptee, right? Instead of inheriting an implementation of adaptee, notice that we're not inheriting. Instead, we keep track of an instance, right, of these objects. Right, notice that we have a one-to-many. We have many instances of these that can be used in many adapters, and then we're going to forward. Right, we're going to forward operation C, D, and so on and so forth. We're going to forward them to the adaptee with operation A, B, C, and whatnot. Yes. So the implementation is fairly straightforward, but the same idea, right? The client is expecting one type. We have another type, and so we're going to inherit. We're going to implement the interface that is expected, but instead we're going to wrap an instance of this object, right? I'm going to forward all the methods to this instance that we're wrapping around inset one. Okay. So here it is. We have the adapter, the same name as before, the same name as we had earlier, right? The adapter, but notice that we're only implementing inset one because the client presumably is expecting inset one, but we're not extending, right, inset two. Also notice that we're going the other way around, right? Before you have a client that was expecting inset two, right, and we implemented in terms of inset one. Now we're going the other way around, right? Here's a client who's expecting inset one, but we have instances of something that's of inset two. Yes, so we're going the other way around, but it's the same idea. Basically, we implemented set operations in terms of individual elements, but here we're going to go the other way around. We're going to implement the individual elements in terms of the set operations. Yes. And this actually hints at a strategy that's coming up. What if you wanted to go both ways, right? What if you want an object that you can treat it as either one, right? You could treat it as inset one, or you could treat it as inset two without having to care, right? Of which type it is, right? That the underlying framework would know just how to use it, depending on what interfaces it implements. Not there yet. We'll be there in a minute. But for now, the strategy is that I'm implementing the interface that you're expecting, but I'm implementing it in terms of this int set2, not by inheritance, but by delegation, right? I'm keeping track of an instance of the adaptee. Right? There's we might have a couple of constructors, based on how is it that we might want to use it, right? If we already have an instance of an adaptee, an object that we want to use, right, we can pass it along so that we can assign it to our local adaptee that we want to use. Use this particular instance to do the conversion, right? Or we can create our own, instantiate one, with something that's empty, an object that is empty, it's not configured, doesn't have any particular values, and then we'll use it as the adaptee to shuffle, to shuttle the methods back and forth to the adaptee. So the implementations. Notice that before we had implemented the set operations in terms of the individual methods. Here we're doing it the other way around. Here we're implementing the individual methods, right, that deal with the individual integers. We're writing it in terms of the set operators, right, the adaptee union with. Right. So before we had implemented the union with, the difference, right? We had implemented all those in terms of the add, member of, remove, right? And here's where we're going the other way around, right? We're going implementing the other ones in terms of the first. Right. So to implement the add, basically we want to add an individual element, right? And so we instantiate a singleton that has that one value, because union with only knows how to deal with sets, right? It doesn't know how to deal with individual elements. Right? So instead we give it a set of one element. Right? That's what we're doing here. The int set2 impl dot singleton, right? It only knows how to deal with whole sets, right? But in our case, we're the way we trick it, right, is that we create a set of one to be able to work with add. Okay. Basically, we're creating a union of another set that has just one single element, and we can repeatedly implement add with adding sets of just one single element. Remove, same thing. We can write remove in terms of difference, right? We can write it in terms of differences. Again, all these difference from and union, right? They all deal with sets. They don't know how to deal with individual elements. So the way we fake it is that we are always instantiating a brand new set that has that one single element, right? So inset impl dot singleton value. That's why we have the singleton. We're creating a brand new set of that one element. Again, obviously, we're not looking at the actual implementation, how the is superset or difference from. Presumably, the library already knows what to do, right? We're assuming that the library already does this for us, right? And it's being written in terms of this library. We're just trying to write one in terms of the other. Okay. Iterator. Right, it's basically converting it back into a list, and we know that list already implements the iterator interface, right? So we can just ask for the iterator, and we get the iterator of integers. So that's pretty basic. Okay. All right, excellent. So we were able to go back and forth, convert. If you were expecting inset1, right? I can give you something that implements that interface, but it's written in terms of the other. Or we can go the other way around. If you're expecting inset2, but I have actually inset1, right? I can write one in terms of the other. And we look at two different strategies, right? Either using class inheritance or the composition, the delegates.